Hello, homework 8.1. So first break this into, so the one thing I always say is add the square, implied square, so we can sort of keep it consistent. And then I'm going to do the square root of, and I factor this. This is 5 times 5. So I'm going to go with, there's 2, so I'm pulling out pairs. Whoop. And I just pull out 1 5. So this is just equal to 5. Here in number 2, there's a negative sign on the inside. When we have an even, this is even. So if we have an even root, we need positive on the inside. So this is does not exist. Later on, when you get to, I think, pre-calculus as well, you learn that square root of -1 is this number I. So technically, this guy equals 6I, the imaginary number. But you guys don't need to know about that. But I just want to sneak it in. And this next one, the negative sign's on the outside. So the very first thing I'm going to do is just rewrite the negative sign. And then I have square root of 3 times 3. So I'm dealing with pairs, 1, 2. And then I only pull, so that's the thing that I know throws a lot of people off, is this idea that we take 2 and we pull out 1. So this becomes just -3 because we have one of these pairs. 2 to the 50, the fourth root of 256. 256, I believe, is 2 to the 8th. So, which means that I'm dealing with fourth root of 2 times 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 2. Yeah. 1, 2, 3, 4, 5, 6, 7. All right, I did enough of them. So now this is a fourth root, so I'm pulling out 4 tuples. 1, 2, 3, 4. 1, 2, 3, 4. So this ends up equaling 2 times 2, because I pulled out 2 of the 2's, which is 4. 125 is 5 cubed. So, and because these are 3, I'm pulling out 3 tuples. 1, 2, 3. So this just equals 5. I need to make sure you rewrite. So this is 8 is 2 cubed. So I have 3 of them, and here we can see that we're doing 3 tuples. 1, 2, 3. So this equals 2. 512 is 2 to the 9th. So that means I need 9 of these. 1, 2, 3, 4, 5, 6, 7, 8, 9. This, I'm doing 3 tuples. So 1, 2, 3, 1, 2, 3, 1, 2, 3. So every 3. And I'm left with, which is 8. You can, like from that sheet over here, where is it? So you could have looked at 512 here and seen that it's also equal to 8 to the third. So that is something you could do. So if you'd done that, you could have gone with here, cube root of 512 equals cube root of 8 times 8 times 8. If you want to go with just that equals 8 cubed. And then again, you're pulling out 3 of them. So you would just get this equal to 8. I mean, as you get more comfortable, you can go that way as a sort of a shortcut. No, note, we have here, this is, oops, I need a pen. This is odd. So when we have an odd of a negative stuff, this will equal negative times the square root of stuff. So I see that's odd. I see a negative sign. I'm going to put my negative sign right there. Odd, negative sign, put in my negative sign. I would have added a fourth root of negative 256 and had an extra DNE as an option there to sort of to refocus, remind you guys of that. So I've pulled out my negative sign, and now I'm looking at the cube root of 5 times 5 times 5. Because this is 5 cubed. And so I now I get an answer of minus 5. 32 is 2 to the 5th. 64 is 2 to the 6th. And 256 is 2 to the 8th. So I'm dealing with the 5th root of 2 times 2 times 2 times 2 times 2. Here I'm doing with the negative 3rd root of 2 times 2 times 2 times 2 times 2 times. I need 6 of them. And the last one I'm dealing with the 4th root of 2 times 2, 8 of them. 4. Okay, I got 8 of them. All right. And then I need 1, 2, 3, 4, 5. So I pull out a whole set of 5, and I only pull out 1, 2. Here I need sets of 3. 1, 2, 3. 1, 2, 3. And here I need sets of 4. 1, 2, 3, 4. 1, 2, 3, 4. So I'm left with just the 2 here. Remember, I have the negative sign, and I have 2 times 2. So it equals negative 4. And here I have just 2 times 2, so I just get 4. At this point, I like method 2 a little bit better. But technically, I'll do it both ways. So we have the 7th root of B, 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 B. Yeah, I'm like not liking this. So this is 1, 2, 3, 4, 5, 6, 7. 7 here means I need groups of 7. And I pull out a B. So this just equals B. But the doing the second method is taking the 7th root of B to the 7th equals B to the 7th to the 1/7. And then I get B to the 7 times 1/7, B to the 1. As you get more comfortable, you can maybe skip that step. You just know that you're timesing by 1/7. Especially with this next one, I'm going to do method 2 because I do not want to draw 21 X's. You could, I don't even want to draw, so we could do 21 X's. Now, so I'm going to rewrite this as X to the 21 to the 1/7 power, and that becomes X to the 21 times 1/7, which equals X to the 3rd. And so knowing how to do both methods is kind of helpful. 169 is 13 squared and P to the 24th. And this is an implied square root. So I'm going to have 13 squared times P to the 24th, all to the 1/2 power. 13 to the 2 times 1/2, and P to the 24 times 1/2. So I'll get 13 to the 1, P to the 12th. Here we have a negative sign, so we're going to need negative signs. Rewrite all my negative signs. I'm pre-writing my negative signs. This is an implied square root. 64 is 8 squared. So we have 8 squared W squared to the 1/2. 8 to the 2 times 1/2, W to the 2 times 1/2. And we're left with 8 times W. (216) happens to be 6 cubed. And here we have P to the 9th. Oh, or you could go 2 cubed times 3 cubed. It can be either way, how you want to write it. So I have this 6 cubed P to the 9th to the 1/3. And I'll distribute that 1/3. So I have 6 to the 3rd times 1/3 and P to the 9th times 1/3. So I get 6 to the 1, P to the 3. First, I see that this is odd, and I have a negative sign, so that becomes negative cube root of 27C to the 36. So I'm just going to have these negative. And I'm pre-writing my negatives. 27 is 3 cubed. So I have 3 cubed C to the 36 all to the 1/3. I don't need those guys. So I have 3 to the 3rd times 1/3 times C to the 36 times 1/3, and that equals negative 3, since this is equal to 1, and then this is equal to 12. So C to the 12. Sorry about that grumbling sound. And last up, So 4,096. If we go back to this table, we can see 4,096 is 2 to the 12th or 4 to the 6th. So we've got either way how we want to go about it. Let's go back to the problem. Where are we? Okay. So this is, oh, I need a back pen. This is 2 to the 12th. So we have 2 to the 12th times k to the 12th, all to the 1/6 power. 2 to the 12 times 1/6, and we have times k to the 12 times 1/6. And that simplifies to 2 squared k squared, because that equals 2 and that equals 2. 243, again, if we look at the table, 243 is 3 to the 5th. So we have, this is 3 to the 5th. So we have 3 to the 5th times c to the 40th, all to the 1/5 power. And that becomes 3 to the 5 times 1/5, c to the 40 times 1/5. And this is equal to 1, and this is equal to 8. So we'd have 5 c to the 8th.